kinetic energy of system of particles. So we consider the system of particles in three-dimensional space. So let's consider from a group particles we select one ith particle with velocity vi. Kinetic energy of one particle or ith particle is 1/2 of mi vi square. And if we make a sum of these kinetic energies over I from 1 to n, so we sum all kinetic energies of all points together, so we get kinetic energy of system of particles. So it is a sum of kinetic energy of individual particles. For further calculation, we will not divide forces to internal and external ones. So I will write it for further calculation. We will not divide forces to external Fe and internal Fji. And because it was suitable for calculation with momentum and angular momentum. Now, it is convenient to divide forces to working forces Fv and reaction Fr. Working forces makes during the process mechanical work. So makes mechanical work. And these forces doesn't make mechanical work. Based on the law of change of kinetic energy, of particle, we can write that kinetic energy at state 2 of particle I minus kinetic energy of state 1 of particle I is equal work of force. So it is integral of Fi working force dr from Ri1 to Ri2 plus integral of reaction force. It's a resulting reaction force Ri1 Ri2 dri. Okay, so this is a law of change of kinetic energy applied to one particle, and if we sum these equations, this is ith equation of the system of equations. So if we sum these equations from 1 to n, we get sum of this over I minus sum of kinetic energies at the beginning of the state, and it is equal sum of integrals of Fi working forces dri from I is 1 to n. Why this is missing here? Why sum of these integrals of reaction forces is equal 0. Because, as we said already, the work of reactional forces is equal 0. They doesn't make mechanical work. Why? Because if we admit that the reaction forces can make work, as it is stated here, so there is a reaction force to particle I and it makes work, no problem. But to every reaction force there belongs action force, which is the same size but opposite direction, so it makes the same amount of work but with opposite sign. So if this reaction force makes work with plus sign, this action force makes the same amount of work but with minus sign, and it compensates these works together, and sum of these works is equal 0. Okay, so there shouldn't be vector sign. Okay, so this statement remains. So we can rewrite it as a kinetic energy of all system of particles at state 2 minus kinetic energy of all system at state 1 is equal work of working forces. So finally, we can say that change of kinetic energy of system of particles between two states, K2 minus K1, is equal to work of working forces between these states. Yes, and this is this term. if all forces acting on or within the system are potential forces, then the law of conservation of mechanical energy, is applicable also in the case of system of particles. So kinetic energy at state 1 of the system plus potential energy at state 1 of the system is equal sum of kinetic and potential energy at state 2 and is constant. Okay, so it's potential, also kinetic energy and potential energy.